Hey, hello, G8 students. How are you after Easter break? I'm fine. Okay, thank you for writing test. I'll check this test in this week. You'll see your grades in e-register, not in the Google Classroom, but in e-register. Okay, still we are doing a chapter forces, so still it's the same chapter, but today start to do, in my opinion, the most difficult in the case of mathematics, buoyant force or buoyancy. Okay, so right topic, a buoyant force. Okay, so what is buoyancy or what is a buoyant force? Buoyant force is related with Archimedes' law, is related with density of the object, density of the liquid, and it's related with the fluid. So at the beginning we have to review a few important terms like a density or like a fluid. So start with point number one, fluid. What is a fluid? Okay, fluid is or liquid or gas. Okay, fluid is non-solid. Okay, so let's write a fluid is a liquid or gas. Okay, very important, is not solid. Okay, so give me examples of fluid. Okay, it can be a water, it can be air, and a liquid and a gas. Is that clear? But not solid, so it cannot be an ice from water. Okay, it cannot be steel in a solid state. Okay, it cannot be in plastic in a solid state. So everything which is not a solid is known as a fluid. So basically it's a liquid or a gas. Okay, it's very, very important because buoyancy, this phenomenon, is related with fluids, so with liquids and gases. Okay, buoyant force is a force which occurs when object is immersed in the fluid, so which is immersed in the liquid or is immersed in the gas. Is that clear? Okay, please copy this and you will be ready. Turn the video again, and point number two, density. Okay, what is the density? I hope that you remember that density is a ratio between mass of the object and its volume. Okay, so let's write density is mass of the object divided by its volume. So by using equation, it is d equals m over v, formula triangle dm v. So you can write that if d is m over v, you can write that mass is density times volume, or volume is mass over density. Okay, what is the unit of density? The standard unit of density is kilogram per meter cubed, and in this chapter I'm going to use only this unit. So mass will be expressed in kilograms, volume will be expressed in meter cubed, then density will be expressed in kilograms per meter cubed. Again, we did this. It's also a revision. In this case, you have to know how to measure density. I hope that you know, that you remember these base methods. Okay, you can immerse object and check how much fluid is displaced, so it will be very, very close to our topic. And second is to use some mathematical relation shapes to calculate volume of the object. In both cases you have to know mass. Yeah, so here as a revision, read, find in your notebook, and now please stop video for a moment now and find the chapter about density, the topic about density. We did this around October or November. Yes, and you have to find, maybe not October, November, closer to December or January. Okay, you have to find the topic about density, especially how to measure. Okay, so please stop video now for, let's say, 5-6 minutes. Find in your notebook the topic about the density and read now how to measure density. When you will be ready, let's turn video on again. Okay? So, a few minutes later. Okay, so what is this buoyant force or buoyancy? Let's look. When any object, is immersed in the fluid, so in liquid or a gas, it displaces a particular amount of this fluid. Okay, today let's focus on the liquid. Let's imagine that you have an object which is immersed in the water, as an example of liquid. Okay, object is placed in the water, and the level of water rises because water is displaced. Is it clear? The space occupied by the water now is occupied by the object, so water must be displaced, so level of the water increases. So let's look, don't copy it. Okay, this is our container, yeah, which contains a particular amount of water. Okay, and we have an object, F block or something, which will be placed in the water. Okay, so what happens? Now, when object is immersed in the water at all, the level of the water is not longer the same, because object occupies some space. Okay, and this space which is occupied by the object now cannot be occupied by the water. So water is displaced from this space and occupies another part of the container. Is it clear? And what is important here? Important is then volume of the water which is displaced by the object is exactly the same as the volume of the immersed part of the object. So let's use V with index of F, volume of the fluid which is displaced. Okay, volume of the fluid which is displaced. Displaced. And let's mark with symbol of V with index of O volume of the object which is immersed. Volume of the maybe immersed part of the object. Okay, and what is important? Maybe let's name this as a point number 3, displaced fluid. Okay, please don't copy it. Okay, it will be point number 3, displaced fluid. Okay, so again, object, when it's immersed in the fluid, in my case in the water, occupies space which was occupied by water before. So what happens? Water cannot occupy longer the same space. It is displaced. And what is important? That the volume of the displaced part of the fluid is exactly the same as the volume of the immersed part of the object. Okay, so this volume of the fluid is exactly the same as volume of the object, the red one. Why? Because now object occupies space which was occupied by water. Let's imagine that object has 1 meter cubed. So what is the amount, in the case of volume, what is the amount of water which is displaced? Of course, 1 meter cubed. Okay? So now please stop video, write point number 3 and displaced fluid. And let's write maybe something like this as at the beginning. Okay? When object is immersed in the fluid, it displaces a fluid. Okay? When object is placed in the fluid, then part of the fluid is displaced. And please copy this picture. Is displaced. So please copy this picture with the same symbols, with the same description. You can use the same colors. When you will be stop video, when you will be ready, please turn the video again, and I will be talking about Archimedes' law. Okay? So I'm changing slide. Please stop video, copy point number 3, and I'm changing slide about Archimedes' law. Okay, Archimedes' law, the most important moment of today. Okay, what is Archimedes' law? Archimedes' law is about this displaced fluid and about the weight of this fluid and about the buoyant force. Okay, so please don't copy yet, I'll tell you when. So let's again imagine our container, which was filled by, let's say, water, okay, and in which an object of certain volume is immersed, and due to this, okay, the water is displaced because now the object occupies a space which was occupied by water previously. Is it clear? Okay, so this red region represents the volume of the object, and blue region represents of the volume of immersed the displaced fluid, and of course, you know from the previous slide that the volume of immersed part of the object is exactly the same as volume of displaced fluid. Is it clear? Okay, so we can write first part of Archimedes' law. So when object is placed in the fluid, then fluid is displaced. Okay, we know also we can write this a little bit more specifically, that volume of the displaced fluid is exactly the same as volume of the immersed part of the water. We wrote this previously, so this is nothing new. But what is new? That when object is immersed, then additional force called buoyant force starts to act on the object. Is it clear? So let's look. We have another force acting up. Let's name this FB, buoyant force. Okay, what is important here? That the value of this buoyant force depends on the weight of displaced fluid, or more specific, buoyant force is force which starts to act on the object which is immersed in the fluid, and its value is exactly the same as weight of displaced fluid. Okay, and this is the core of Archimedes' law. So Archimedes' law says that when object is immersed in the fluid, then buoyant force starts to act on the object. Okay, so wait a moment, still please don't copy. I'm going to do something like that. Okay, so when object is immersed in the fluid, when object is placed in the fluid, okay, then buoyant force starts to act on the object. Okay, is it clear? What is important? Important is direction of this force. Okay, so this force is directed always vertically up. Okay, this force, I'm going to use symbol FB, buoyancy, is directed up. Okay, this is second. And third, very important, which will be described mathematically in, I hope, a little bit easier way than the word description, but let's write by words. Value of this force is equal to the value of weight of displaced fluid. Ta-da! Okay, so again, you immerse object in the fluid. Due to this, fluid is displaced because object occupies space which was occupied by the fluid before. Okay, so level of fluid increases. And additionally, a new force called buoyant force, which is directed up, starts to act on the object. And the value of this force is exactly the same as weight of displaced fluid. Is it clear? If yes, please stop video, make a pause, and copy this as a point number 4. Okay? So point number 4, Archimedes' law, and please draw this picture and write these 3 bullet points. When you will be ready, move video again, and will be next part. Okay, a few minutes later. Let's write this bullet point number 3 mathematically. We wrote here that value of buoyant force, so buoyant force, is equal to the value of weight of displaced fluid. So we can write a formula that buoyant force is the same as weight of the fluid displaced. Okay, how to write weight of displaced fluid? Mass of the displaced fluid times gravitational acceleration. This is a weight. Gravitational force acting on the fluid is mass times gravitational acceleration. Remember that this is mass of displaced fluid. And g is gravitational acceleration. Okay? Okay, so what is mass of displaced fluid? I hope that you remember formula triangle for density, mass, and volume. Density is linked by mass and volume by equation that density is mass over volume. So mass can be replaced by product of density and volume. Okay, so except mass, I'm going to write density times volume. So, except mass, I have density, mass of fluid, so density of fluid, times V, volume, volume of displaced fluid, which is the same as the volume of immersed part of the object, but let's write density of fluid, which is displaced, times gravitational acceleration. And again, I told you that density of volume of displaced fluid is exactly the same as volume of the object which is immersed. So finally, we can write expression for buoyant force as product of density of fluid times volume of the object times gravitational acceleration, or I'm going to use shorts, except write fluid, I'm going to use dF, and except the right object, I'm going to use VO, obtaining final form that buoyant force is density of fluid times volume of the object times gravitational acceleration, and this is our final equation. Okay? So please stop video, copy this, read this twice or 3 times. When you will be ready, turn it back, and then you will see next slide. Okay, so to conclude, Archimedes' law and buoyant force. I'm writing this force again. Buoyant force depends on three factors. Depends on the density of fluid. It's very, very important. It doesn't depend on the density of the object. It depends on the density of fluid. Volume of the object, which works only with immersed part, because when object is partially immersed in the fluid, like a ship, you have to take only the part of the object which is immersed, and times gravitational acceleration. So remember that buoyant force depends on the density of fluid, not on the object, density of fluid, volume of the object, and it works only when whole object is immersed, and gravitational acceleration. Okay? Again, I'm talking only about buoyant force. I'm not talking about the total force, the net force acting on the object which is immersed in the fluid. I'm talking only about the buoyant force. Remember that object also experiences a gravitational force, but this is not the part of today's lesson. I'm just talking about buoyant force. Is it clear? Okay, so let's do one example with calculations about the buoyant force. So let's write example 1. Okay, so your task is to find buoyant force acting on the object. Okay, of volume of, let's say, 2 meters cubed, immersed in the water, of density. Water has a density 1000 kilograms per meter cubed, and use G as 10, not 9.81 but 10 newtons per kilogram. Okay, please stop video for a moment. Okay, copy this text and calculate buoyant force acting on the object. Yeah? When you will be ready, so let's say after 3 minutes, please turn video again and we will check together. Okay, 3 minutes later. So what is a buoyant force? Buoyant force is a product of density of fluid times volume of the object times gravitational acceleration. We know density of fluid. Density of fluid is given in standard units. You don't need to convert. You can write just thousands. Volume of the object. Object is also given in standard units. Meters cubed. You don't need to write unit. Times gravitational acceleration, which is also given in standard units. You don't need to write units. You have to multiply 1000 times 2 times 10. 1000 times 2 is 2000. 2000 times 10 is 20,000. Remember, this is force, so newtons, and the direction is up, because buoyant force is always directed up. Okay. I hope it's not difficult topic. You must know how to measure density. Remember, to measure density we have to know mass and we have to know volume. So this is a revision of our previous material in one of our previous lessons. You have to know this description that when object is placed, is immersed in the fluid, then fluid is displaced, and the volume of the displaced fluid is exactly the same as volume of the immersed part of the object. Okay, it's also very, very important. Next, you have to know this Archimedes law. I wrote this in 3 bullet points. Yeah, I hope that you've noted this. If not, please move video back and write these 3 points about Archimedes law. Yeah, it was finally that buoyant force is then when object is immersed in the fluid, then buoyant force starts to act, and the value of this buoyant force is always equal to the weight of displaced fluid, and its direction is always up. So mathematically, it can be written that buoyant force is the product of density of fluid, in which object is immersed, times volume of the object, of course of immersed part of the object, times gravitational acceleration, which on the Earth is equal to 9.81 newtons per kilogram. You can use value of 10 newtons per kilogram. Remember, in the case of calculations, you have to use standard units, so volume should be expressed in meters cubed, density should be expressed in kilograms per meters cubed, and in this set of units, gravitational acceleration should be given by newtons per kilogram, which is of course the same as meter per second squared. Okay? Remember equation. I hope that you remember how to calculate. You don't forget mathematics. One I can give you extra is formula triangle for buoyant force. You can plot it, let's say here, that buoyant force is a product of density of fluid, volume of immersed part of the fluid, and the gravitational acceleration. So we have one part which is up, buoyant force, and three parts which are down. Okay, so always to calculate, let's say, density of the fluid, you have to divide buoyant force by V times G. To find V, you have to divide F by D times G, and to find G, you have to divide F by D times V. Okay, so formula triangle also works with these three force symbols. Okay, so our next lesson will be about, let's say, sinking. Okay, conditions of floating on the surface, conditions of sinking. I'm going to give you expression for gravitational force acting on the object and for net force, and then you will see how to use buoyant force in more complex applications. Okay, thank you for watching. See you next lesson. Stay at home. Good luck and goodbye.